Namaskar everyone. Today we'll be dealing with a very important topic of physics, and that topic is the mechanical properties of fluid, where we'll be talking about the uh, fluids in motion. So we'll be starting the topic with fluid dynamics. So when we talk about fluid dynamics, that means fluids are in motion, and we already know that fluids are certain things which can change, which can move, which can flow. So that is what the fluids are all about. So when the fluids are moving, there is a very important property which is there, which is called viscosity. And viscosity is what? Viscosity is the property of fluid by the virtue of which an internal force of friction comes into play when fluid is in motion. And this force, this kind of frictional force, opposes the relative motion between its different layers. Let me show you how these are changing. Suppose this is a liquid which is moving. It has different layers, and all the different layers are moving with some different velocities. All are moving with different velocities. So if we talk about the velocities, the bottom of the liquid, the fluid, will be at the very small velocity or minimum velocity, or we can say it is at zero also, because it will remain almost at rest. And the topmost layer will be moving with the maximum velocity. So there will be a force of friction, kind of friction I should say, which will be there between the different layers of the fluids or the liquids. So that force, that thing is called viscosity. Now how to calculate that viscosity? For that we have a very important topic, very important thing called coefficient of viscosity. So coefficient of viscosity is what? Let's talk about the coefficient of viscosity. We have a two different layer. Say the layer number one, the bottom layer is called the M layer, and the above layer is called the N layer. Since both are moving with different velocities, as we had seen in the above case also, as we have seen in this upper case also. So this one is moving with velocity v, and this is moving with velocity v plus dv. We can say after a certain interval of time the velocity has been increased, so it becomes v plus dv. And similarly, the distance also changes. It is covering a distance of x, and it is covering a distance of x plus dx. So the force, very important, the force of viscosity or viscous force, that depends on two very important factors. The number one is the area, I should say the area of contact. Number two, it depends on the velocity gradient. Velocity divided by distance. It depends on velocity gradient. And when we combine these two things, we'll get F is directly proportional to area into dv by dx, and the constant, that is a very important, or the coefficient here is called the coefficient of viscosity, eta. So if we calculate eta from this equation, we'll be getting force upon area. I'll be writing that thing also. We'll be getting force upon area. If we talk about eta here, so eta will be equal to force upon area. The negative sign is a very important significance. Force upon area and whole divided by dv by dx, which is called the velocity gradient. Velocity divided by some distance. This is the velocity gradient. So a very important thing is there. So right now we'll be just discussing this thing. The rest of the part we'll be discussing in the next video. Thank you.